Welcome to the Capital Light Assembly podcast brought to you by Edison Manufacturing and Engineering. Edison is your contract manufacturing partner focused on capital-efficient assembly of complex mobility and mobility-adjacent products that are not well-suited for highly automated production. I'm Brandon Bartnick, Vice President and General Manager here at Edison, and you're listening to part of a special series here focused on how to reliably scale production of autonomous vehicles. So how can you execute and scale that production building autonomous vehicles? This is part of our core business, an area where we have a lot of experience and expertise. We're using this series as a way to share some of that knowledge for anyone who's going through this process. So hope you enjoy it. There's 7 total tips, 7 episodes here. So check out the ones before and after this. And please enjoy. The next tip is to plan for traceability in the manufacturing process. So we don't take a one-size-fits-all approach to quality. We base our approach off the APQP process, Advanced Product Quality Planning in the automotive world. And you're using then failure modes and effects analysis of at design and process levels with DFMEA and PFMEA, which are used to inform a control plan, which really set the requirements and in the plan, the quality plan for the production system. And there's flexibility there, right? And to figure out what are the key risks and the things that could go wrong, and the likelihood of them going wrong, and if they go wrong, how big of an issue is it, right? RPN. And one of the things that you'll see in the autonomous vehicle world is the hardware better stay on, right? And that sounds obvious, but you have safety critical sensors and components that, when assembled, you need to know that that's been done correctly, and ideally have documentation to show that. And so the approach that we take is traceability there, right? So you have bolts for the most part that are used. Say you're using a bolt to attach a bracket to a vehicle which has a LiDAR sensor on it, right? You want to know that every one of those bolts has been installed correctly. And so what you're capturing is torque value and the angle at which that's applied to assure that that has been done correctly. And there's a range in which you could do this. So at the minimum level, you can have a quick click gun, right, where you highly calibrated gun that you're applying, click, you get the right torque, and you move on. And look, I know that this has been done correctly, but a better approach, especially when you're looking at the criticality of these items from a cost and an impact perspective, is to capture and document that information, the torque and angle information, along with that unit. So what we're often deploying is something with a DC torque gun that's closed loop and in real time is capturing that data and is putting it into our digital MES, manufacturing execution system, and capturing it and logging it alongside that product. So you have a product record that shows for each of these fasteners that have been deemed safety critical, you have the right countermeasure in place. And so here, torque and angle capture, and it's documented. And so then when the vehicle is produced, it comes with, and when it's final, it gets signed off, and you can say, hey, okay, this operator did this and at this time, and here's proof that everything was done correctly. And I don't know if that sounds like overkill or if it sounds obvious, depending on where you're coming from, but like this is, when you think about how critical some of these components are, it's a necessary step often in the autonomous vehicle world. So you have to plan for that in the manufacturing process, and you need something that is adequately robust to account for that. And there's one other key dimension of traceability that we often prioritize, and that is something like serial number tracking, right? So when you have these components, again, let's take the LiDAR sensor as an example. You want to know which LiDAR sensor is on your vehicle. When you're producing 1,000 per year and you have them driving around the road and different aging vehicles and stuff, when you have a recall upstream, you want to know which vehicles are affected here. And you know that by looking at serial number information for a given sensor. And it also then can be tied with software numbers and software versions and a few other things. But the message is like you need to be able to document that core information, capture serial numbers for key components that are installed on every vehicle. And take that as input that then goes into that build book or the birth certificate that goes along with the vehicle when it's completed. So there's a lot more here. This is just scratching the surface of quality here. But the key tip here is plan for traceability in your manufacturing processes.